Alright, I thought I'd give you a little bonus bell work. Let's talk about some falling things. Problem number one. Bob falls into a well. If he splashes down 2.4 seconds after falling in, how deep is the well? To solve this problem, no, I'm not going to have fancy deltas and everything as I do this because I'm doing it on the fly. I'm going to use the formula where displacement, in this case I'll use delta y, but remember I'm not putting deltas in. Delta y equals vi times t plus 1/2 a t squared. Please forgive my notations. Knowing this, if Bob's falling in, we have to then recognize that vi is 0. A is going to be our negative 9.81 meters per square second. We're going to just kind of ignore the whole units for this exercise. And of course we have to multiply that by the time squared. So 2.4 seconds, and that gets squared. So by calculating that, let's take a second. I'm going to pause my recording. I'm going to calculate it here. Actually, you know what? I'm going to let it run. I'm just going to calculate it in the calculator here. And we'll find out how deep the well is with this calculation. So you go ahead, pause your recording while you calculate it out. Ready? Go ahead, pause it. Did you pause it yet? Did you remember to do that? Alright, when I've got that in there, half of 9.81 times 2.4 squared, my answer comes out to be 28.25. 28.25 meters. And I'm going to put a negative on there because it is a negative displacement because you're falling down the well. Okay, nice little example. Let's look at the next nice little example. Now Bob is down in the well. He throws a rock towards the top of the well. If Bob throws the rock straight up with the velocity of 23 meters per second, will the rock make it out of the well? So instead of trying to figure out, is yes or no, don't worry about that. Worry about how high up that rock goes. We established in the last problem that the well was down 28.25 meters, right? So we want to find out, if he throws it 23 meters per second, how high will it go? To do that, remember my notations are going to be goofy here. I'm going to say v final squared equals v initial squared plus 2 times the acceleration times the displacement. I'm going to use a y. So v final at the top of the rock's trajectory, v final is going to be 0. We said v initial is 23. And of course, you've got 2 times g, so negative 9.81 times y. Alright, so now we're able to begin the solving process. So I'm going to take 2 times 9.81, and that comes out to 19.62. 19.62 there, and then 23 squared. Let's do that real fast. 23 squared, 529. Let's type in a couple numbers here. So I still have 0 equals here. 0 equals 529. Now that's squared meters and squared seconds. Plus negative 19.62 times y. And then to solve that, I'm going to have to subtract my 529 over. I'm going to divide by my negative 19.62. So what is 529? Negative 529 divided by 19.62. According to that, the height that my calculator is saying to me is 26.96 meters. 26.96 meters. And then you have to ask yourself, okay, how does that answer the question? Will the rock make it out of the well? Well, if the well is 28 meters deep, he only throws it 26 meters up. He comes up a little bit short. So I just threw these two questions at you just to give you a little something to think about when you're trying to solve these problems. Just give you a little more background to work with. All right. I hope that helps.